Good morning, all, and thank you so much for taking the time and joining us at Blue Team Summit. We are very excited to introduce Lambda, Lateral Movement, and Data Access, two new Velociraptor artifacts to enhance DFIR investigations. I am Phalgun Kulkarni. I work at Strauss Friedberg, a level blue company. And in my role, I work on various cyber incidents like APTs, ransomwares, threat hunts. And personally, I love reversing malware and all things memory forensics.
Hi, everybody. My name is Kostya Ilioukevitch. I am a cyber manager at Strauss Friedberg, Level Blue company. My personal interests in the field lie in those really weird one-off cases where you don't really know what's going on. It gives you a little bit of a head scratcher just because it keeps everything interesting. So today we're going to be talking about how Lambda can help enhance your analysis. As we all know, during the scoping and identification phase of your engagement, you're going through a lot of artifact collection, collection, analysis, especially when it comes to lateral movement and data access. That's really where Lambda does come in. So the idea here is that there are plenty of different forensic artifacts that you typically want to collect. And then from then on, instead of having to go through the circular motion, you run everything as part of one hunt within Velociraptor, one for lateral movement, one for data access, configure it as you so wish, and then provide some normalized results as output for you to walk through. That way, everything is in a simple format for you to go through as you're looking through different types of forensic artifacts as it relates to these two topics. And lastly, how that data can be leveraged to, for example, visualize or report on it in a little bit of an easier fashion as you work through your data set. So, I don't know about you folks, but I'm pretty excited to enhance my analysis. The agenda for today, we'll start off with an overview of Lambda. We'll then talk about some of the forensic artifacts that are included as part of this triage set for LMDA, Lambda, lateral movement, and data access. Then we'll be discussing some implementation of the Velociraptor artifact. We won't be diving too deep into VQL syntax, but just to give a high-level overview of how it works. Lastly, we'll be giving two rudimentary examples, kind of proof of concepts of what you can do with that data set to visualize it and report on it. So for those of you that haven't heard of Velociraptor, but are huge fans of Jurassic Park, unfortunately, you might be in the wrong place. I am a huge fan of Jurassic Park, but I do also know and love Velociraptor, the tool. It's a DFIR tool created by DFIR practitioners. It is open source and it is currently supported by Rapid7. It is a great tool out there, really allows you to collect data and analyze data in scale. And that's really where the tool really comes into play for your triage analysis. That way you can really quickly collect all the data set, run through it, identify what systems you really need to dig deeper on, maybe grab a forensic image. That's where Velociraptor really comes into place.
All right, thanks, Kostya. Now let's get to know what Lambda is. Right, so in any DFIR engagement, one of the commonly asked questions or one of the commonly tasked goal is to identify how many systems were accessed by threat actors. And to identify that, we enumerate lateral movement. So in an environment, if or when a threat actor compromises that environment, they typically move laterally to multiple systems in the environment. So this movement is coined as lateral movement. Another commonly asked questions by stakeholder is what data was accessed or what data was exfiltrated. Again, when threat actor compromises environments, they typically tend to move laterally to systems using RDP or other remote management tools in search of sensitive data that may be hosted on file servers or SQL servers, and their aim is to exfiltrate that. All right, so let's see how we can identify Lambda evidence. Basically, we use Windows features as forensic artifacts. And when I say Windows features, I mean, for example, if you use RDP to remote into other systems, and if you right click on that icon, you may get a list of systems that you commonly RDP into, and that is called Windows jump lists. So these are there to enhance user experience. But we also use jump list as an evidence of lateral movement and data access. So here we can parse the data present in jump list and prove it and use it to prove that a user at a certain time laterally moved to a certain system using remote desktop protocol. So basically, that's how we utilize Windows features to prove the evidence of Lambda. All right, let's get to see some artifacts that we implement in our artifacts to enumerate lateral movement. Right, beginning with the one of the most commonly used artifacts is Windows event logs. We include a plethora of event IDs. This is just a small representation of what we include in the artifact. So beginning with login and logoffs from security and RDP event logs, including the psexec service install, as well as PowerShell remoting and server message block or SMB access activities.
Moving on to additional artifacts outside of event logs. Sometimes event logs are not available, so you do have to look into other places. One of those places are registry keys. So we do look into some registry keys as it relates to the usage of outgoing RDP. We also look into some registry keys as it relates to mapping remote shares. So essentially mapping a remote system to yourself or to the source system. We also look into shellbags and LNK files, essentially for any references of data access to a remote system. While technically that is data access, it does have a component of lateral movement, which is why we include it. Shellbags is not included by default. It's part of the configurability of Lambda. The other artifacts that we do have, user access logs, one of my personal favorites. The only roles that we do consider within Lambda are file, remote, web, and FTP. File will be the most common that you will find across your investigations. But it can be a very, very rich data set, especially when event logs have been cleared or not available or rolled over. Next up, we do keep in mind and consider some RMM tools within our LM artifact. TeamViewer, AnyDesk, Gatera, including Splashtop, Screen Connect, OpenSSH, WinSCP, and PuTTY. Depending on the RMM tool, it does leave behind some forensic artifacts. Some are a lot more richer than others. So there is obviously some level of confidence with each one of these. Moving on to the data access perspective, in terms of what we consider for parsing for DA, as already mentioned, we talked about shellbags and LNK files and their use in not only identifying lateral movement, but more importantly, identifying data access. Jump list, as Phalgun had earlier pointed it out, as a Windows feature, can be used to identify data access, MRUs, browser access. For example, if a user opens up a PDF within a specific browser. Lastly, we also do look into WinSCP registry keys for any remote access, but more importantly, it's very commonly used for data exfiltration. So it's something nice to have kind of rolled up all in one output.
All right, now let's get to know why we decided to build Lambda and how it actually works. All right, so before Lambda, I used to parse and analyze funds one by one. And yes, it was time consuming. And I was not aware of all the various artifacts that we included in Lambda. And I also used to spend time cleaning outputs from multiple different formats one by one. So this is me hiding my pain. All right, so here's why we built Lambda. As discussed before, it parses a plethora of Windows forensic artifacts into one single place. So you do not need to search for various artifacts, like it's already done for you. Secondly, it provides results into normalized format. Again, you do not need to spend time extracting the most useful information from like thousands of artifacts there are. And third, last but not the least, it includes a master sheet, meaning all the results from all the artifact are combined into a single sheet or a single location that is in a timeline format. So you can easily use that to plug and play with your overall DFIR timeline. Now that's me after discovering and using Lambda. I'm not that bored though. All right, let's get to see structure of Lambda. So like mentioned before, we have multiple artifacts into two separate hunts, and those are very configurable. So you can easily include or exclude different artifacts according to your needs. Then we provide normalized results into two forms. Like one is the master sheet, which again includes all the results in single place, as well as individual results. So in case if you want to focus on, let's say, security event logs, you have the option to do so. And these results are under specific columns. And these columns are catered to ease analysis. So the columns do not include all the information, just the most useful information from an investigation perspective. So let's take a look at certain all the columns that are present in lateral movement. I would like to highlight the description one. It suggests like if it would be an RDP access or a network logon or a PowerShell reporting, etc. And we also use direction column, which includes an inbound or outbound connection, like very helpful in identifying lateral movement and like creating visualizations. In data access report, we obviously include user account accessing the directory or the file. And importantly, we also include file size. So it may aid you in accessing the entire universe of the size of data accessed by threat actors in case there is a need to identify exfiltration or for exfiltration purposes.
All right. Let us talk about how it's implemented, particularly the lateral movement artifact. Now, if you are looking at this picture, it might be a little bit daunting if you don't know VQL or SQL, as they're kind of similar. We won't really talk too much into how it's actually implemented, but I did want to point out at least how the master sheet, which is really the bread and butter, is implemented. What it essentially does is it hijacks the first source's notebook cell and adds its own cell for it that joins in a large chain statement every single artifact source that is defined above. Now, one thing to consider as you're using this is that the master sheet does default to a limit of 50 rows per every single artifact source. So when you do load it up for the first time, you open up your notebook, you click refresh. If you actually want to go ahead and start filtering that data on the entire data set, do go ahead and edit the VQL cell and just do a control F and remove the limit 50. In terms of what this actually looks like on the screen, so here's an example of the master sheet. Once you go into the notebook, it's the first thing that you do see. All of the columns as described by Phalgun earlier, as well as some extra columns as added per just default Velociraptor hunts. Then as you scroll down, if you wanted to look into the individual artifact referenced, for example, terminal server registry, scroll down, the output will be exactly the same as found in the master sheet. So that way, if, for example, you find something interesting, but you want to look more into a target output of, let's say, just terminal server evidence, there you go. So how can we use this data set from a visualization standpoint? So what we'll be going over quickly are two very rudimentary examples using Grafana and Jupyter. From the Grafana aspect, the way that it would work is you would set up a forwarder over to an ELK stack. Then you set up a connector between Grafana to ELK. Lastly, you just have to point it to your desired index that you do want to visualize. From a Jupyter Notebook perspective, we do use a Python module called Velociraptor, which is provided by the Velociraptor team, which allows you to interact directly with the backend API of your Velociraptor server. You can call that from within a Jupyter Notebook, and then using that data set, specifically a component of PyVelociraptor called VeloPandas, that it would output the results of your query over into a data frame. You can just go ahead and use Bokeh as an example to visualize that data within your Jupyter Notebook. So that's a whole lot of talking. Let's see how it works. So first, from the ELK and Grafana perspective, you go into your server events, you go ahead and run the Elastic customized flow uploader. Specifically, we created this for Grafana just to make it a little bit easier to complete that visualization. All it does is it changes the column names a little bit, but it also adds the visualization at the very end of the index, just so you know exactly which one to go ahead and try and visualize. Then once you're in Grafana, you go ahead into your data source. You go to adding the source, click Elasticsearch. Then you give it a name, give it a connector. Then you specify the actual index that you want to visualize. And then for the time field name, you want to have it as ID. Once that is done, at the very bottom, you'll see this green check mark that says you're all good. You can go ahead and start visualizing. You can click that dashboard button, and it will take you to this screen right here where you can start creating your visualization. So why don't you go ahead and start? You click add a data source. You click the Grafana name, or rather connector source that you just had created. Here we're doing RDP as an example. And then it's done. So from here, you can go ahead and start querying your data. For example, if you want to query on a specific user, just kind of see what their lateral movement map looks like. Or if you want to filter on time, it's all built into Grafana, pretty simple to use. Just make sure if you did want the actual node graph that you have node graph selected. And just to show you an example of some, again, a rudimentary lateral movement node edge graph, this is how it would look like. Now, for the Jupyter Notebook perspective, it's going to be a little bit more complicated because it's so much more customizable. The data set is truly yours to do whatever you want with. First step is always to create an API configuration file. You do have to make sure that the user that you're associating your API configuration has API rights. From then on, you install Velociraptor. Just to give you an example of how you can use Velociraptor to interact with your server, you just point it to your config file. The config file has all your connection details, your API keys, and then you just send a query. Again, this particular example here is using Velociraptor. Velo Pandas has the same exact capabilities, but it'll just return a pandas data frame. So that way, for example, using Bokeh, you can just go ahead and visualize it in a node edge graph.
All right, thanks, Kostya. Now let's quickly take a look at how data access artifact would look like. Right, so it's very similar in terms of structure to LM artifact. Like LM artifact was showcased, we have our master sheet, including results from all the artifacts that we are parsing for data access. We also have individual sheet, if you want to focus on a specific artifact only. Most importantly, we have catered our results to be in a format that can be easily plugged into our data access Excel template, which can be used for stakeholder communications. So let's see how you can use Velociraptor to, let's see how you can go from Velociraptor to an actual data report very easily. All right, entering our data access Excel template. So we have 3 tabs, starting with the Overview tab. We do have some predefined coloring lesion just to identify and distinguish between confirmed malicious activity. And some of the highlights are baked as conditional rules. So for example, if you have words like password or credentials in any of the cells, then they will be automatically highlighted with orange color. And same goes for finance or HR, like very useful in identifying like potentially sensitive files that may be accessed by threat actors. Next, we have a definition of our forensic artifacts. It can be useful for a non-technical audience to understand where the data is coming from. Lastly, for the Overview tab, we have listed some review methodologies. So for example, if stakeholders or analysts wanted to see suspicious user accessing data like during office hours, like meaning let's say at 1 or 2 a.m., then basically they can just use the methodology listed in tier 3 and go from there. So not an exhaustive list, but a good pivot and starting point to interpreting the data provided in the report. Next, we have some what-if scenarios. Again, we list like certain activities conducted by threat actors that may or may not generate data access artifacts on target systems. Very useful in explaining to stakeholders when we do not see evidence of threat actor doing or accessing data, but when they claim data exfiltration. So again, can be very useful in stakeholder communication. And last but not the least, this is the meat and potatoes of our Excel template. This is where actual data will reside. You can easily copy paste data from Velociraptor results into this tab. A couple columns that I wanted to highlight. We do have local time as well for ease of analysis. Like, let's say if you wanted to see a user accessing data at 1 a.m., we have certain keywords being automatically colored with the respective colors, and this can be easily configured in Excel sheets conditional rules. An important point I wanted to bring up is not all the artifacts listed in this Excel sheet or Excel report would represent actual time of data access. So for example, the event time associated with link file is the link file modification time itself. So that does represent an accurate or exact time of data access. But that will not be the case with shellbacks, as shellbacks represent the last modification time of the key that is present in respective user hives. So just an important caveat I wanted to point out. All right, and that is how we execute visualizations with lateral movement using Grafana and Jupyter and present data access reports from Velociraptor.
All right. So what did we actually learn today? What did we talk about today? What are our key takeaways? Today we talked about various forensic artifacts. We talked about how we can take all those artifacts and put it into one single Velociraptor artifact definition that would output normalized results. And also, if your heart does desire to look into the individual output of one particular artifact source, that is available. We've also covered a few POC examples of visualizing that data set, as well as how you can potentially think about reporting that data set right away using tools such as Jupyter, Grafana, and Excel. Now, in terms of how you folks can contribute, at the end of the day, there are going to be always new Windows builds, which means new Windows forensic artifacts. With that, Velociraptor is an open source community. So if you folks have a specific artifact that you want to write an artifact definition for, go right ahead. The community would very much welcome you. A more direct example for Lambda, this was very Windows focused. You know, we have other operating system structures out there, Linux, Mac OS. So if you folks wanted to take the challenge and kind of create the equivalent for one of those platforms, feel free. Lastly, from the visualization side of things, rather, what we showed was very rough POCs. We do have some of the POC examples on our GitHub, which is our next slide. But if you have a more better idea of how you would like to visualize it, if you have a better idea of some of the tech stack to be used, that's definitely something to contribute, as at the end of the day, there are so many endless ways that you can work with this data set, and it's going to be very specific to you as an analyst of how you like to work through your data. Speaking of GitHub, for those of you that want to pass our phishing test, this is going to take you directly to our GitHub page where you can look at some of the artifact definitions. You can put it into your own local Velociraptor instance, give it a go. And one last talking point for me, a few shout outs of people who inspired the creation of the actual artifact definition. We took inspiration from their artifact definitions to kind of get an idea of how we should structure the overall definition syntax.
These are just the meme sources. I love Hide the Pain Harold. For our testing, we use latest version of Velociraptor and the 22H2s for Windows 10 and 11. Thank you so much for taking the time and joining us. I hope you learned something valuable and feel feel free to reach out to me on LinkedIn, like I'm easy to find, or on Discord. And again, all the code base that we have mentioned, including Jupyter Notebook, the Elastic configuration YAML, and the data access template is available on our GitHub. So take a look, let us know how it works. And thanks so much.
Very cool, gentlemen. Very, very cool. We do have a couple questions in here. I think the first one's really been answered already, but just wanted to make sure that this was nailed down. Is this tool paid or free / open source?
Velociraptor itself is open source, so you're free to use it. The community itself actually hosts something called the Artifact Exchange, where you essentially can push your own custom artifact definitions onto Velociraptor's own hosted GitHub that can be pulled down directly. The Lambda in specifically is not on the exchange, but it is available on our GitHub that you can go ahead and just download it's just a YAML file, but we call it an artifact definition. So you can just go ahead and download the artifact definition and just go ahead and use it.
Awesome.
Yeah, thank you all. Appreciate your time and sharing your knowledge today. Joe Mama from the Discord says, how are you feeding artifacts for analysis?
That's a great question. So dependent on the artifact source, we either do parse it directly on disk using built-in support that Velociraptor does have with built-in parsers. With some artifact sources, we do use some parsing tools, third-party parsing tools. For an example, the DA side, Phalgun, if you want to speak a little bit about the built-in capabilities versus tooling capabilities.
The first option would be to use Zimmerman tools, and everything is listed like in details on how you can use the tools or the data access artifact. So I would recommend you to just go to GitHub and just give it a read before using it, so things would be clear. Even if then things are not clear, I am available on LinkedIn to answer any questions.
This is one good question from Josh here. They're asking, how are y'all anticipating Gen AI influences on these tools or processes to affect the way things are done?
My opinion is that it'll help you identify abnormality from normalcy. At the end of the day, from my experience, human intuition still is very important. And having a person look through the data is different than having a tool look through the data. If anything, the tool, such as AI at the current state, will help you identify, again, the abnormalities a lot more quicker. But when it comes to putting it all together into the greater picture as it relates to a large investigation, that's where it might struggle. Phalgun, do you have any thoughts?
I feel like no, I completely echo what you said. I feel like it's just not there yet in terms of Velociraptor, like specifically talking about Velociraptor and implementing that, because lots of avenues where it could go wrong, and people will just like take the wrong information, present it as the right information. So yeah.
Yeah, we're already seeing in some of our matters where some junior DFIR firms are treating the stuff that they get out of some of these AI-driven forensics tools as gospel, unfortunately, and they're coming up with the improper facts and timelines for that. So it's going to be a problem.
Thank you all. Thank you, Kostya and Phalgun, for being here, sharing your information with us.
Thanks so much.
Thank you, everybody.